I believe we are online now. Hello. Here we are finally a little bit late. Apologies, huge apologies for that. We had a couple of technical difficulties, but nevertheless, this is going to be an amazing discussion. The last Q&A session for this World Cyber Twitter conference, and a very, 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 very exciting one because it kind of like deals with a really major issue for a lot of seabird researchers at the moment, and it looks into tagging effects and how the effects of tags can really affect seabirds and the physiology of those birds and how to best account for them. So I hope this is going to be a really, really vivid discussion. We just video Q&A session. We had the plenary presentations from first of all our plenary speaker, Kyle Elliott, who is with us today as well. And we also had a presentation from Rachel Auburn, also sitting here in the panel, who was actually talking on a methodology that might actually avoid using heavy tags, but rather like makes it possible to use the lightest and still get a lot of behavioral data out of it. The other third plenary and panel member that we have sitting right now here with us is Morgan Gilmore. She gave a presentation yesterday, and she's also someone who just uses a lot of GPS tracking technologies, and it's just like really interesting to get a little bit of an insight into just a normal researcher's everyday life and how to for tagging impacts in birds. So I guess we can just start the session straight off, and I think this is all a little bit about like discussing the general effects of tagging. But Kyle actually already summarized them really well before, but also like just giving researchers recommendation how to deal with those kind of like assess them in the best way. And that's actually really, really where I want to start off as a question to Kyle directly at the beginning. What do you think, like if as a person that uses biologging technologies, recommend me, how should I really assess the tag attachment? How should I control for it and make sure as representable as possible?
Well, that's a great question, and it's a difficult one to answer because, of course, you're limited by the tag you're trying to use, and you're probably trying to use already the smallest tag that you can. I think the first step is just being aware that these tag effects occur, and to try and consider where these tag effects might be happening, how they might be impacting your data. It's simple to do some very basic measurements to have control birds where you look at reproductive success and perhaps trip duration and body mass, but maybe these parameters aren't the most sensitive ones to tagging effects. So another possibility would be to try and have a small study, a side study within your work where you use very small devices and very large devices. I don't know, for instance, if you put on a GPS which had a large battery, perhaps you want to have 5 days worth of data, and then you could have a small section where you just put on a very small GPS which only brought back a few hours or a couple of days worth of data, and you can compare those two. So I guess that's that would be the direction I'd suggest. From my own work, it seems like behavior is very, very sensitive. So time spent flying, time spent diving, those would be the most sensitive parameters. Whereas because they can make those adjustments, other parameters aren't necessarily as sensitive. So chick feeding rates might be not as sensitive because they might be able to accommodate that or compensate for that at least over a relatively short period. So you put your GPS logger out for 5 days, well, maybe they don't feed themselves as much and they feed the chicks just as much. Or if you look at body mass, again, there's a lot of variation in body mass, a lot of other things which contribute to body mass. So again, it's not nearly as sensitive. So I'd suggest, if you can, having a component of your study that's well thought out and where you compare the effect of your devices in terms of behavior, some measure of behavior with the effect of a smaller device. I think that would be really, really useful and not done nearly enough.
yeah, that's already really, really good suggestions. I think I think they're really great suggestions, but I think they're unfortunately not used as often as they probably should be used in the literature, which I sometimes find quite unfortunate. And as you already stated before, that not being able to find an effect doesn't necessarily mean that there is no effect. And yeah, I think that's kind of, it seems to be like a little bit the approach that people are taking in the literature, almost like, and it's tempting. So Morgan, what did you so far use? Did you try to account for tag attachment at all in your studies? Did you use reproductive success?
Honestly, I have not. I've been aware of tag attachment. One thing, I'm not presenting this right now, but I have been putting GPS tags on frigate birds, and frigate birds are notoriously difficult to deal with anyway. They're just really skittish generally, and so it's really hard to assess their behavior in relation to people to begin with, and then to try to put tags on them. We really don't know how that's affecting their behavior at all. And so we actually tried some dummy tags that were maybe a lot lighter, just to figure out even the attachment method for a frigate bird. We tried putting it on the back, and we ended up putting it more successfully on the tail, under the tail feathers. And so before we even put any tags out, we had to just do the dummy tag thing. And as far as monitoring their behavior goes, we haven't accounted for it specifically in our studies, but I think just keeping a general eye on their behavior in general in the colony, and just looking at the data that we get back, looking at the GPS tracks, they all seem, I don't want to say normal, but you know, it looks like the birds are still doing what they probably do if they're not tagged, where they are taking longer trips and going to where we think that they forage. And I guess their behaviors don't appear to be too erratic, so I think that is a good sign. Also, the birds I tracked tend to go to the same place multiple times, and so I think that repeatability of going to the same foraging location probably also suggests that it's not affecting their behavior too much. Frigate birds are also interesting in that they obviously don't dive into the water, and they don't land on the water either, and so they need to continuously stay afloat in the air to get their food. And so that is something that we needed to consider when putting tags out also, just because it might not be reducing their drag in the water like diving birds, but they still are flying with it like literally constantly until we take that tag off. So that's something we've been aware of, but again, it seems like the birds are probably okay, but we do need to probably do some longer term studies on that.
Yeah, that's really interesting. And yeah, just a little bit from myself, like we have been looking and comparing breeding success between tagged nests and non-tagged nests, but it's really interesting. So we had a kind of short discussion before we started this live Q&A, and Kyle actually mentioned that not necessarily handling, if we really accounted there for handling, because we could also just be measuring actually handling impact rather than tagging impact. So that's a really difficult thing to tear apart as well. Rachel, I'm sure you have been involved in tagging studies before as well. So what did you do?
I think a lot about kittiwakes, and I have also worked with MERS, and in those studies we've measured stress hormones, we've measured time that birds spend at the nest together, we've looked at food delivery rates, those kinds of things. I think in general it's really hard to find that metric that might give you an actual effect unless you're really weighing the birds down. And certainly for kittiwakes, reproductive success is so variable across the large colony that I work at that it's a metric that's so far down the line that I think it's really hard to use that to measure tagging effects. One thing, Kyle's comment earlier got me thinking about, potentially using like a really small accelerometer and not putting a GPS tag on that bird. You could measure say, you know, how much time did that bird spend preening on the water versus, you know, foraging, comparing between the birds with the two different tag types. One thing, just a couple weeks ago, we tagged a western gull with a harness attached tag, and when we let that bird go, you know, it did normal things, and then there was this moment where it was flying really funny and it was looking around, and I think it was this moment where the bird saw the tag on its back, and it was like, oh, wait, what is that? How do I get that off? Like, what's going on? And then it proceeded to, you know, continue on its way. But, you know, they noticed the difference, and I think there are some subtle behavioral things that happen that you might not necessarily think about.
Yeah, that's really interesting that you mentioned gulls there, and Morgan has been talking about the frigate birds. It's really variable between species, and I think that's really interesting as well. So maybe Kyle, you could elaborate a little bit more on that. Like, so how do we kind of like minimize stress for the birds just by changing attachment methods as well? Like, so maybe varying between harnesses or like tessa tape attachments, dependent on the species. Could you do that? Yeah.
Yeah, no, I think Morgan made a really good point there, that you know, saying that she was putting the devices as far back as possible underneath the tail coverts, and so there are basic principles from hydrodynamics that you can consider when you're attaching devices. Going back to the work of Rudy Ben Ash, and almost 20 years ago, I think we need more of this research really verifying these different types of tag attachment. But just in terms of the basic principles, I would imagine that drag would be far more important than load. And yet in the literature, because it's easier to calculate, load is often considered more than drag. And so by placing the device back as far as possible, the flow separation is going to go as far back as possible, and therefore the amount of water, the amount of turbulence the bird has to drag with it is going to be much smaller. So I really think trying to put the device as far back as possible, and in places such as underneath the tail coverts where it's somehow covered up, so it's not really affecting the flow and streamlining as much. I think that's a really important first step. And then some more research looking at these different placements. For instance, there was a paper on gannets out a couple of years ago where they actually showed that putting it on the tail was worse because it caused an imbalance, and the bird wasn't flying as smoothly. So I think a combination of trying to consider these basic biomechanical principles in combination with some actual testing of different locations and their impact on the behavior of the bird would be really useful. And that's where Rachel's suggestion of using an accelerometer, which are really small now. I mean, the accelerometers, which are less than 2 grams, or even down to, I think the TechnoSmart have ones which are 1.5 grams. And comparing birds with accelerometers to birds with a GPS logger that could weigh 20 or 30 grams, comparing those two and looking at the differences in behavior and potentially in biomechanics as well, because the accelerometer is telling you about the acceleration, the wind beat frequency, and so forth. I think that would be a really useful direction to go with these studies. And there's the Gannet paper did exactly this.
Yeah, that's a really interesting one. I really like the fact about the gannet paper, just because still tail attachment is like the most frequently used method for gannet tagging, and I think the main reason for that is just the longevity of the attachment, which is just so much better on the tail than it is at the back. But yeah, I think there are all those trade-offs that one has to consider when tagging birds, and sometimes I think maybe the like rethought about. But yeah, no, really interesting. So you were talking about accelerometers. So I guess accelerometers as a method to measure effects of tag attachment in comparison with GPS tags, I think it's probably valid to say that a 1 gram tag compared to a 20 gram GPS tag probably has very little effect, if at all. But there's another thing. Obviously, we get like more and more tracking technologies coming in, such as accelerometers, GPS tags, TDRs. And there is this kind of like huge urge for people to deploy all of them at the same time and get this like amazing data set. I find that whole thing kind of like amazing, and I would probably be really tempted to do so as well. But there are also alternative methods, like, for example, the one that Rachel kind of introduced earlier. So by just using GPS data and potentially the lightest tag that you can get, you can still kind of infer behavioral information. So Rachel, could you just like shortly outline like the benefits of like directly maybe measuring it compared to like your methodology? Obviously with it, but like maybe it's still a good choice.
Yeah, so I think we're still in that cusp where, you know, for these smaller species, we do have to make this choice, but, you know, tagging technology is improving so quickly that, you know, a couple years from now, we can, you know, we can have the tag of our dreams and have it be, you know, 8 grams and have it do what we want to do. But there's, you know, there's other things to consider. There's cost of tags, there's how you want to attach them, all these things. So, and it's also your research question. So if you just need GPS data from your birds, you're really interested in where they're going. You want some simple behaviors. It does seem like seabirds in general have this transiting behavior where they're heading off to a foraging area. They search for food. You know, maybe they sit on the water and forage. So we can identify those things with a GPS tag with just that data stream if you sample at a high enough resolution to catch those behaviors in the species that you're looking at. So for a kittiwake, that might be kind of complicated if they're alighting on the water for, you know, less than 2 minutes. So you need to sample at a higher resolution than that if you want to know all the places that bird lands with just the GPS tag. Versus in an albatross, maybe they would tend to spend more time on the water once they landed. So it really depends. I think it's species dependent, but having a tool to identify really simple behaviors, I think is helpful, and also should be good for comparing between species and between studies, which I think we haven't quite gotten there yet in terms of, you know, looking across all of our studies and combining these metrics of movement.
Yeah, that's a really good point. I think you made a really interesting one there as well. So like, yeah, obviously I was talking about like advances and being able to deploy a lot of GPS devices on one bird, like albatrosses, for example. But yeah, there are loads of other birds, like Adam Kane just presented earlier, like storm petrels, like one of the smallest seabird in the world. And yeah, we are now able to deploy GPS tags on them just about, if we stick to the 3% rule. We wouldn't be able to deploy anything else on them. So like methodologies like the one you introduced are incredibly valuable to still derive a lot of like behavioral information from those GPS tracks. So Kyle, what I found really interesting during your presentation as well is that graph that you actually showed, like how basically deployment weight kind of stays constant rather than going down, although we have this kind of continuous miniaturization. So what could you please just comment on this kind of like general behavior of scientists to try to deploy as much as possible on like the seabird?
Yeah, for sure. I mean, there's certainly this temptation, and it's clearly there in the literature that, okay, well, at first we could just put on a timed effort burn, and that was amazing, and that was enough. And then they got very, very small. And so now we're able to put on an accelerometer and a TDR, and that's amazing, and that was wonderful. But now, okay, now that those are small enough, okay, now we can put on a camera logger, and you know, and likewise, we're talking about physiological, putting on physiological analyzers, you know, heart rate, but also lactate, measure uric acid, all these different devices, and the bird is just so geared up with these wide variety of different tags. And of course, there's always this appeal because you get more and more data. But I think this goes back to what Rachel was saying, that we can often get an awful lot of data from fewer devices, and I think that's something worth considering. For instance, if you were to have GPS tag, but then with a small accelerometer, perhaps you wouldn't need to sample as frequently with a GPS. Maybe a GPS point every hour will tell you enough about spatial distribution, and from the accelerometer you can infer paths in between as we improve our ability to extract data from the accelerometers. Same with geolocators. I mean, it seems like geolocators are passé now, and this is antiquated technology, but maybe with improved statistical programs, improved analysis, and particularly if you have a geolocator with a GPS for a subset, maybe the data we can extract from a geolocator is much more than what we could extract a decade ago. Same thing with a camera logger. I mean, if you can put a camera logger on for a small subsample birds, and then have an accelerometer on the same bird, or GPS on the same bird, and we can figure out what the GPS signal is telling us, or improve what the accelerometer is telling us from those small subsample of birds, maybe then we don't need the camera anymore. So I really think that improving the statistical tools and really getting the most out of these perhaps more primitive devices holds a lot of promise.
Yeah, absolutely. I absolutely agree with that, especially because I now turned into this person that generated this massive amount of data, and that's actually something that we've been discussing yesterday in the last plenary video Q&A session. So if you're interested in general tagging technologies and how to deal or how to assess foraging behavior, then that might be a good session to look at. So that's the last plenary Q&A yesterday that we discussed with Antje Steinfurt as a plenary speaker. This massive amount of data, but you actually don't have the time, and you don't really have the possibilities to analyze it completely, sometimes just for the sake of generating it, and it doesn't really add anything to your research question. So I guess like sticking with the research question is really, really, really important, especially nowadays considering weight. So yeah, this is all really good. I tried to check on Twitter if there were any questions, but like I would really like to ask a question that Rachel, funny enough, wrote down in our site small tiny chat window, and it basically is a question towards Kyle, and it asks if drag and load differs between air and water, and how think about that when we're kind of like assessing tag weight and the impacts on birds.
Yeah, for sure. I mean, air versus water are very different media. In terms of load, for a flying bird, load is very important, but once you go underwater, it's not just load, but buoyancy that becomes very important. So from Archimedes' principle and volume becomes very important. So for a flying bird, the absolute load is going to impact the induced drag, so the amount of drag that the amount of power that the bird is going to need to stay aloft. But many birds are flying at very high flight speed, well above their minimum power speed. And so if you remember back to kind of the penny curve type of idea, they're flying in the area where drag is far more important. So I think for flying birds, drag is probably much more important than load. Underwater, there's several studies which have shown that clearly the buoyancy is important, and that birds are picking the depth of neutral buoyancy, and if you add something that changes that buoyancy, they change their dive depth and try and accommodate for that with the presumed effects on prey that they're able to capture. In terms of drag in water versus in air it's primarily the frontal cross-sectional area which is important, whereas in water, this area is important. So for a flying bird, you'd want to have something that is as where the cross-sectional area is as small as possible, whereas for a bird moving underwater, it becomes the surface area which is exposed to water, which becomes more important. So the overall surface area which is exposed can be very important, and then even the texture of the device. So if it's a very streamlined device, it won't be cause as much turbulence as a device that might have a rough surface. So yeah, I mean, and then you have species such as MERS, which have to deal with both air and water, and then you have to try and decide which one is more important, right? And it probably depends on the situation. A bird with a chick might be flying an awful lot, whereas one that's incubating is perhaps not flying as much, and maybe the diving is more important. I wish I had a better answer for you, but those are a few thoughts.
Yeah, no, that was really good. That it kind of actually leads really nicely in a question that Corey is asking on Twitter, and it basically relates. So we are all talking now already for like quite a while about tag attachments, but like which metrics would really be affected by tag attachments? So which ones are the ones that we really have to look at when we talk about tag attachment? And that question literally goes to all three of you, I presume. But yeah, let's start. And just because I guess he has the most insights on that one.
Yeah, I think that the parameters will really depend based on the species, right? I mean, so if it's an underwater species, perhaps diving is really impacted. Whereas if it's above water, perhaps it's flying, which is really impacted. I think of it as being a kind of a cascading effect where flight and dive costs are most impacted, because this is physically what's happening, is that the biomechanics are being impeded, and therefore the cost to move a unit distance underwater or above water is the first thing which is impacted. So energy costs. This then leads to behavioral adjustments, so time spent diving, dive depth, or time spent flying, or flight speed. And then those behavioral compensations will impact things like chick growth rates if they fly less and therefore feed the offspring less, or body mass if they forage less for themselves, and then that will lead to impacts on reproductive success and survival over a long enough period. So I think there's those kind of cascading effects from very short-term behavioral effects, which are a consequence of energetics, to longer-term effects on reproductive success and survival, which might be more difficult to detect, particularly because then there will be other things which are impacting those, predation or parasitism or whatever. Yeah, and I think it'll be really species dependent. So I would imagine that Morgan's frigate birds would be impacted in a very different way than Rachel's kittiwakes and my murres.
So yeah, that was a general answer to everyone and for everyone. I don't know, is any one of you really wanting to add something to this? Morgan or Rachel, anything?
Yeah,
Please,
I can add a few thoughts. One thing I think with attachments, as we go through and choose what type of attachment we want for our logger, is we're really trying like, it's easy if you're working sort of chick-rearing birds or incubating birds where they're coming back to the colony, but then the next step is to understand where birds are going the rest of the year. And we have geolocators for that, which are small and attached to leg bands. And if you don't catch your bird back, that bird will carry that logger for presumably the rest of its life. But they're pretty small. But then the next sort of step is attaching loggers that might stay on the bird. If you're using a harness, that harness might stay on for a couple years. Right now we're working on a project here off the Oregon coast where we're suturing loggers to murres. So those tags do come off after a couple months. But there's certainly trade-offs with that. Trying to get larger tags to attach to birds for a longer period of time is challenging, and it's very hard to pick the method that will get the data that you're looking for and have the least amount of effect on your study species.
Yeah, certainly. Tag attachment is a really tricky choice to make, and I guess there are like a lot of factors to consider, and it's not only Kyle, you're there twice. Sorry, maybe that's just my computer doing weird things. No, but like, yeah, it's certainly something to consider, and it's sometimes really hard as well to make the decision which attachment to use. What I really thought was really interesting in presentation early on as well is that he actually said that subcutaneous tag deployment, so actually putting it under the skin, is probably a really good way of going on about it, or like suturing it on. but like all those kind of methodologies are really hard to get licenses for. So I guess there are like loads of like different considerations one has to take in to account for those kind of things. Yeah, I have a couple more questions for Twitter before we are almost finished as well. So one of them is from Sirder, and I think it's a really interesting one because it goes in a completely different direction, something we haven't really discussed right now yet. And that's, did you ever in any of your tagging studies actually observe any behavioral bullying of tagged birds? So actively excluded from other things, or I don't know, from the colony? Maybe that goes out to Kyle first.
Kyle, I think you're muted.
Yes, you are. Kyle, could you just click the unmute button?
Oh, there we go.
Yeah, now we can.
Sorry. Yeah, okay. So in terms of bullying, I haven't observed you know, a bird which has been completely pushed out from having a tag, but certainly having its mate play with the tag or pick at it, and have other birds play with the tag and kind of peck at the bird and irritate the bird. That's fairly frequent if there's a large tag on the back for murres and for kittiwakes. Anyone else?
Yeah. So Morgan, any observations? No, Morgan doesn't have any observations. Rachel, did you observe any behavioral bullying?
Yeah, so we do tend to color mark our tagged kittiwakes. So I'm not sure if it's you know, chasing because of color marking or chasing because of tagging, and it doesn't happen all the time. And my general sense is it happens when we use orange paint, so we stopped using orange paint. They're red-legged kittiwakes, so maybe they're specially attuned to those colors. But yeah, we've had a couple sort of chasing events where, you know, you release your newly tagged bird, they're flying a little funny, they're not quite sure what the thing is on their tail, and then somebody comes by and chases them. And that was actually what happened with the western gull that we recently tagged as well. So we released that bird and somebody else noticed and came over, and you know, there's a squabble on the water, and then you know, our tagged bird flew on its way. But I haven't noticed sort of very yeah, anything more than that, those types of interactions at the colony.
So yeah, I guess that's really interesting. I guess we are kind of running out of time right now, and I don't really want to drag this on too long because it's Good Friday, and I presume you all have other things to do as well after the Twitter conference finishes. So I guess like that's quite a good note though to kind of like wrap this whole thing up. So in summary, basically, tagging impacts are really, really important to consider and really should probably be considered in more studies than they actually have been so far. Like it's really hard to account for them completely and fully, but like that's maybe just something to be aware of and like consider when analyzing your data. So the only thing I can really say right now is like huge thank you to our plenary speakers. I think this was like a really interesting plenary discussion, not completely without any technical difficulties, but I think we're all working on this. And yeah, so really, really thank you for joining us, Kyle, Morgan, and Rachel. And yeah, I hope you will enjoy the rest of the Twitter conference, which is just going on until basically almost until UTC 12 o'clock at night. And then, yeah, we will see you again next year. Please let us know on Twitter how you really liked those Q&A sessions, because it's something completely new, something we just started this year. So we would really like to hear how you liked it, and if you want us to do the same thing next year, if you want to expand on it, want us to expand on it, just give us a little bit of feedback on it. Yeah, thank you very much, and then enjoy the rest of the conference. Bye.